Hello everybody. In section 17.3 we are going to talk about vector fields. And before we get into the first example and look at an actual vector field, there are a couple of definitions and first a point of notation. From now on, throughout this section and also for the remainder of the course, we will often refer to the vector r. And when you see this vector r, it represents the vector xi plus yj. So when you see, at least in 2 space, and in 3 space, it represents xi plus yj plus zk. So in the next example, in our first example, you're going to see r, and we really mean the vector that's xi plus yj. So just so that you know what this means when it shows up. Okay, now let's talk about vector fields. A vector field in 2 space is a function, a vector valued function, whose value at a point xy is a 2-dimensional vector. And similarly in 3 space, the function f of xyz is takes on values that are vectors in 3 space. So let's look at an example to really clarify what we mean by this. We have 2 grids over here on the right, and we're going to look at 2 vector fields. So we're going to draw the first vector field f1 of xy on our first grid and f2 on our second grid. So we're going to do that second. Let's look at f1. So f1 is defined that at any point xy, it's defined as minus yi plus xj. And like we've done many times before, when we encounter a new idea, let's make a table of values to just get a feeling for what this vector field actually looks like. Okay, so table of value, we need points xy, and then we are going to write down what our vector field function values are at particular points of xy. And since we want nice values, let's look at easy stuff. So we could look at the point 1, 0. We're going to look at the point 0, 1. We're going to look at minus 1, 0. We're going to look at 1, 1. And we're going to look at 2, 0, just to get a feeling for what this looks like. Okay, so for the very first one, I'm going to do that in some detail. So what does f1 of 1, 0 look like? Well, it is minus yi plus xj. So y in this case is 0 and x is 1. So we have minus 0i plus 1j. So this is just the vector j that we are getting when we are plugging 1, 0 in for x, y. Let's draw that. So here is our x-axis, here's our y-axis, and the point 1, 0 is over here. And so at 1, 0, the output of this function is j. J is the unit vector that is 1 unit long and points straight up. That is j that I just drew. And so that is the output right here. Now we can do the same thing for our second point, 0, 1. And again, when I plug in 0 for x and 1 for y, out comes minus I. And that is the output for at the point 0, 1. So that vector is minus I. That is a unit vector pointing in the negative x direction. The next vector we're looking at is when we're plugging in x equals minus 1 and y equals 0. And you could pause if you like and see if you can draw in those vectors on your own, and then start up again to see the rest of this. So you find that you get minus j at minus 1, 0, and you get minus I plus j when you plug in 1, 1, and you're going to get 2j when you're plugging in 2, 0. So if we draw those in, we get the following vectors. We have minus j over here. We have I minus I plus j, that is that little diagonal vector right here. And then we have 2j at the point 2, 0. So that is twice as long, pointing in that direction. And you can look at the full solutions to see what the vector field looks like when you're drawing in more and more and more vectors. So I could draw in a few more. Let me change colors to just show what a few of the ones look like that we haven't seen. This one would show up. This one would show up. We have this vector right here. We have this vector right there. We have this vector. So you kind of can see that you have this circular motion going on. Something like this. And yeah, we could compute all these vectors. I'm not going to draw the entire vector field in, but so how you have this swirling motion going on for vector field number 1. Let's look at vector field number 2. So I'm going to add on to my, the color changed slightly, that's okay. So we're going to look at F2 right here of xy. And that vector field is just R. And remember, R is xi plus yj. And so we can do the same thing when we plug in 1, 0, we're getting I. So I'm doing this for F2. When we plug in 0, 1, we're getting j. When we're plugging in minus 1, 0, we're getting minus I. We're getting I plus j at 1, 1, and we're getting 2I at 2, 0. Now, what do those vectors look like? Let's draw them. So at 1, 0, right here, I get the vector I, so unit vector pointing to the right. At 0, 1, I get the unit vector j pointing straight up. At minus 1, 0, I get this unit vector pointing in the negative x direction. Which other ones did we have? At 1, 1, I have I plus j, so that is this vector right here. And then we had 2I at 2, 0, so that is this vector pointing in that direction. And I'm going to draw a few more, again in green. And here it's pretty easy for me to draw. I know exactly what they're going to look like because all of these vectors are pointing straight out from the origin. And they get longer the further away you are from the origin. And that makes sense because the vector field says, well, at any point, draw a vector that is xi plus yj, and so if x and y have bigger inputs, then we get longer vectors, and we are always pointing straight out from the origin. So when you see vector fields, this is probably the only vector field that we are going to draw by hand. Usually vector fields are drawn by technology, and so a lot of the examples that you will see will show you vector fields where the vectors are often automatically